Hi, this is Suresh, physics faculty, and today I'm just about to give you a small lecture on the structure of atom as part of the selection for BYJU'S faculty, online faculty. The structure of atom, as the name says, is the study of what is inside the atom, and as we know, atom is the smallest particle of matter. Its size is about 1 angstrom, is so small that it is not visible to the normal eye. So what is inside the atom? This was studied by various scientists, namely Dalton, J.J. Thomson, Rutherford, Niels Bohr, and Sommerfeld. The study of or the structure of atom had evolved over a period of time, and what we know today is actually the effort of all these scientists. The atom as it appears now is actually uh, I have drawn this atom on the board here. Before I look at the board there, let us just find out what the particles are inside the atom. The, according to the Bohr's model, the prevalent model now, the existing model, accepted model now, is that of the model prescribed by Niels Bohr. The Bohr's model actually explains the stability of atom. The atom is not going to shrink nor collapse as it was found in Rutherford's model. We know the atom is electrically neutral, means the total positive charge which normally resides in the central region here, which is called the nucleus, and is due to the positive charge is due to the proton, and it is balanced by electrons, which have shown here in the form of circular orbits. The electrons are revolving around the nucleus in circular orbits continuously, but they are confined to same orbit. Then the energy of the atom in this state, the revolving of electrons in particular orbit around the nucleus, in that state the energy of the atom is fixed. In case the electrons are jumping from higher orbit to lower orbit, then the atom as a whole emits a photon of energy. This was proposed by Niels Bohr. So as long as the electron revolves in a particular orbit, the energy of the atom is constant, and there will be an alteration of the energy in case the electron jumps from a higher orbit to a lower orbit, or a lower orbit to higher orbit. In such a case, you can see here the energy of one single photon is given by this theory is actually based on the quantization of energy. Here E refers to the energy of single photon, and the small h is a symbol for Planck's constant, a universal constant, and the symbol nu, it refers to the frequency of the emitted photon. And if the atom is making a transition, meaning the electron is jumping from a higher orbit to a lower orbit, where its energies are respectively E2 and E1, then the emitted photon will have an energy equal to difference in energies of these two levels, or the frequency of the emitted photon will be equal to the higher energy level, the energy in the higher energy difference, the energy in the lower energy state, divided by Planck's constant, E2 minus E1 by h. So we know that currently we know that the nucleus is a central region and a very small portion of the entire atom. And in the nucleus we have the protons, which are positively charged particles, and it gives the mass to the atom. The mass of the atom is mainly due to the protons and of course the neighboring particles, which are neutrons, which have zero charge and also reside in the same nucleus. Put together, proton's mass as well as neutron's mass constitutes the mass of the atom. Whereas the electrons which are revolving around the nucleus in circular orbits have very negligible mass as compared to the protons and neutrons. So what is the significance of these electrons is the charge carried by the electron equals the charge present on the proton. Even though their mass is negligible, the charge is equivalent of the proton charge. So if you have one as in the case of hydrogen atom, in the hydrogen atom we have one proton inside the nucleus and one revolving electron, and as a whole the hydrogen atom is neutral.